This is part 2 of the section 5.3 rational numbers section. Example 1 says to express each terminating decimal as a quotient of integers reduced to lowest terms. A lot of times in math, they make the directions sound harder than they need to be. So when I see like express your decimal as a quotient of integers, well, quotient means division. So if I have a quotient of integers, it means I have an integer divided by another integer. Well, looking at that, really, that's just a fraction. So translating these directions of example 1, really just rewrite your decimal as a fraction that's reduced. You wish they would just say that, I know, but unfortunately they don't. They are currently terminating decimals because they all end. We have 0.9 as A, B is 0.86, C we got 0.783. And there's a pattern for rewriting these types of decimals, these terminating decimals, as a fraction. So you're going to ignore the 0 in the whole number spot and just focus on whatever digit or digits are in the decimal portion. In this case, it's the 9. And that's going to be your numerator of your fraction to begin. I draw my fraction bar. And you're going to have a power of 10, like 10, 100, 1,000, etc. on the bottom. So I'm going to put the 1 there. And then just simply count up how many digits you have in the decimal spot, also in the numerator there, and that's how many zeros you put. So if I have just 1 digit in the numerator, because I had just 1 digit in the decimal spot, I'm going to put just 1 0 in the denominator. So that gives me 9/10. Now I'm going to see if this reduces any. Now this one is easy enough. You could just look at it and see clearly that it's not going to reduce any further because only the number 1 divides into 9 and 10. But it doesn't hurt to practice using that feature on the graphing calculator for the more complicated fractions. So if you type in 9 divided by 10, hit the math button like I showed you in an earlier video in this chapter, enter twice, math button, enter, enter, you will see that 9/10 is already reduced. So 9/10, final answer for A. Let's try another one. B, 0.86. So again, I don't care about the 0 in the whole number spot. Scoop up whatever's in the decimal spot, the decimal portion of the number. In this case, it's 86. Bring over your fraction bar. So the decimal portion always goes in the numerator. Don't forget there's a 1 because there's some power of 10 on the bottom. And count up how many digits you have in your numerator. 86, I got 2 digits because I had 2 digits in the decimal portion, and that's how many zeros you throw down beside the 1 in the denominator every time you have a terminating decimal. Notice that these answers are all proper fractions with the bigger number on the bottom. So I have 86 over 100. Now let's go ahead and reduce it. I'm going to reduce it on the calculator. So typing it into the calculator, 86 divided by 100, math button, enter twice, and the reduced fraction answer is 43 over 50. So I'm going to go ahead and jot that down, equals 43 over 50. What's nice too with these types of questions is you could check that your answer at the very least is conveying the same exact decimal. So if I typed in 43 divided by 50 and I hit enter, that is 0.86. And now see, I'll do that one in blue pen. I'm going to ignore the 0. We got 783 in the decimal spot because it's 0.783. 783. The decimal terminates, so it's going to be some sort of power of 10 in the denominator. Go ahead and put your 1 in. Now we got 3 digits, 783. So because we have 3 digits, I'm going to write 3 zeros. Now just see if it reduces. So you might want to have your graphing calculator close by. 783 divided by 1000, math button, enter, enter. And I end up with the same fraction back again on the main screen, which means it's already reduced. But hey, it doesn't hurt to check just to make sure. So 783 over 1000 is my final answer. So what if instead of a terminating decimal, you have a repeating decimal and you want to convert that to a reduced fraction? The process is a little bit different. If you've already skimmed ahead, you can see all the bars above the decimals, meaning that they do repeat. And looking at the directions, example 2 says to express now the repeating decimal as here we go again with the quotient of integers stuff, reduced to lowest terms. So meaning rewrite it as a simplified fraction. And they put the bar above whatever repeats, and that's the pattern that the number would repeat forever. So I have 0.6 with a bar above it, meaning 0.66666, etc. And it's going to start the same way as when we're rewriting those terminating decimals as fractions, in that you're going to scoop up just what's in the decimal portion under the bar. So in this case, it's a 6. You're still ignoring the whole number, the 0 in the whole number spot. So in this case, 6. And you're even going to still count how many digits you just wrote that are now currently in the numerator. So here, if I have just 6, I have just one digit that's repeating. So count the number of digits that are repeating. But here's where the difference comes in, is what you put in the denominator when you have a repeating decimal. You're going to put that same number of digits that you have in the numerator as 9s. So if I have one digit, I'm going to put 1 9 on the bottom of my fraction. If I had 2 digits that were repeating, I would put 2 9s, so 99 in my denominator. If I had 3 digits repeating, I'd put 999, so that I have 3 9s on the bottom of the fraction. You get the idea? So here in example A, I had just one digit repeating, a 6, so I'm going to put 1 9 on the bottom. Now we reduce it, 6 9ths reduces to 2/3. Reduce it in your head or the calculator, it doesn't matter to me, but the final answer should be 2/3. Let's try B. We got negative 0.45 repeating. Before we forget, let's go ahead and bring that negative symbol over. Ignore the 0 in the whole number spot. What's under the bar that's repeating is 45. So in other words, this decimal is negative 0.45454545, etc. So 45 is what's repeating. Because I have 2 digits, the 4 5 that are repeating, I now need 2 9s in my denominator. Go ahead and reduce this, negative 45 divided by 99. If you're reducing longhand, the top and the bottom are divisible by 9. So it is going to reduce to negative 5/11 as the final answer. Feel free, as one way to at least make sure that you're on the right track, you could type in negative 5/11 into your calculator, hit enter, and you do have that 0.45 repeating decimal. C, negative 0.3334 repeating. Again, let's bring down the negative symbol so we don't forget it right away. In other words, this decimal really means negative 0.3334, 3334, 3334, etc. So we got 3334, that is repeating. All the digits under the bar. So I have 1, 2, 3, 4 digits that are repeating the same pattern forever, which means I need 4 9s on the bottom of my fraction. I'm going to type this into the calculator just to see if it reduces. And when I try it, I get the same fraction back again. So this is the final answer. The negative symbol, by the way, on the graphing calculator is located on the very bottom. It's to the left of the enter button. It's to the left of that the enter that you use like equals button. That's my final answer circled there in black. Example 3, there are two different ways the homework and the test could potentially word these types of questions. They might say, find the rational number that's halfway between the two numbers in each pair, or they might just simply say what I have in parentheses, I have AKA, also known as, they might just simply say, apply the density property. It means the same thing, regardless of the way they word the directions. So the density property really just means you're going to find the midpoint, the middle point on a number line, and they're giving to you the two endpoints. To do that, all we have to do is add the two numbers they give to us. So I'm going to write a plus symbol and then divide that value by 2. So add the two endpoints they give to you together, divide by 2. So really we're just finding the mean average, honestly, of those two endpoints. A, find the halfway point between 3/5 and 2/3. And it's up to you. If you want to do it longhand, go for it. The only problem is we're going to be adding fractions and you have to first get the same denominator. So it's going to be a little time consuming if you choose to do it longhand. We got 3/5 plus, because remember we add the numbers, 2/3. I know, not the nicest numbers. And then we always, in the density property here, divide by 2. I'm going to make my calculator, my graphing calculator, do the work to save myself some time. You absolutely need to type those parentheses around the numerator. That's your way of telling the calculator that both of those numbers are located in the numerator. The parenthesis buttons on the graphing calculator are located above your 8 and your 9 buttons. So I'm going to write parenthesis 3 divided by 5 plus 2 divided by 3, close the parentheses, divided by 2, math, enter, enter. The reduced final answer is 19/30. If you wanted to check to make sure your answer seems reasonable, if you're trying to visualize all this, you might want to convert everything to a decimal, because I think decimals for the most part are easier to visualize than fractions are. So if I do 3 divided by 5, that was 0.6. The other number they gave to us is 2/3. So the original question was actually asking us what number on a number line is exactly halfway between 0.6 and that's 0.6 repeating. The calculator can only hold so many digits, so it had to round that last digit to a 7, but 0.6 and 0.6 repeating. Our answer is going to be 19/30. So when I type that in, yeah, that seems reasonable. That 0.6 with the 3 repeating would be halfway between 0.6 and 0.6 repeating. I'll go ahead and jot that down. So that was 19/30. Final answer. If you're doing it longhand, if you just are not a fan of the calculator, or you just like to do it longhand for whatever reason, please feel free by all means to do it longhand. But the final answer you should be getting, doing it either way, is 19/30. If you are doing it longhand, heads up, when you add fractions, you first have to get the same denominator. So 5 and 3, what they could have in common is 15. So you'd have to multiply this fraction on the left by 3/3, and then you have to multiply the fraction on the right by 5/5. So pretty much you're going to multiply those fractions by what's in the opposite fraction's denominator. And then once you are able to add those with the denominator of 15, you would divide by 2. You'd rewrite 2 as 2/1. And then you'd have to skip, flip, multiply. In other words, multiply by the reciprocal. Whew, so it is a lot of work. It's not hard, it's just a lot of work. Definitely more time consuming, but you could still get that 19/30. Let's try B. So B, again, same directions, apply the density property. They give us -2/3 and -5/6. So negative 2/3, I always add with the density property here, the negative 5/6, and then we always divide by 2 is our formula. Now, you could type this just like that on the calculator, that's fine, but right here, I'm technically adding a negative number. If I have a positive times a negative, that's going to make it negative. So if you want to push less buttons on the calculator, plus sitting beside a minus becomes minus. Positive times negative, so it's really like I'm subtracting 5/6. In other words, adding a negative 5/6 is the same as subtracting 5/6. It's like saying, if I add debt to myself, I still have debt, regardless, right? So divide by 2, bring that on over. Now I'm just going to type it in the calculator. If you are doing it longhand, the common denominator, the smallest common denominator for the fractions on the top would be 6. So you just have to multiply the 2/3 by 2/2 to get that bottom number of 6. Let's see what happens on the calculator. Please be aware that on the calculator there is a difference between the subtraction button and the negative sign button. So whenever I am literally subtracting, whenever I have a minus symbol in between two numbers, you're going to use the subtraction button. And I'll show you where that is located in a second. However, the negative that comes before the 2/3 is not in between two numbers. It's just before one number. So they consider that a negative sign and not a subtraction button. So instead of the subtraction button, you're going to use the negative sign button. That's right, use the negative sign. So whenever you have a negative right away, it's not in between two numbers, so it's not subtraction. You're going to use the negative sign button, whereas that minus sign in the middle, you are going to use the normal subtraction button for. Again, don't forget, you absolutely need parentheses around the numerator. So parentheses, and the negative symbol button is right here. It's to the left of the enter button. It's on the bottom row. Totally different then, here's the subtraction button. So I'm going to hit negative symbol, 2 divided by 3. Now, subtraction symbol, 5 divided by 6. Close the parentheses, divided by 2. Math, enter, enter. And my final answer is negative 3/4. If I wanted to check to make sure my answer seems reasonable, negative 2/3 was one of the original numbers they gave to us. Negative 5/6 was another number they gave to us, so negative 0.6 repeating, negative 0.83 with the 3's repeating. We're saying the answer is negative 3/4. And yes, that seems reasonable that negative 0.75 would be halfway between negative 0.6 repeating and negative 0.83 with the 3 repeating. So negative 3/4 final answer. I'm going to go ahead and jot down that final answer. So equals negative 3/4. If you're doing it longhand, not on the calculator, that's perfectly fine. Just make sure you are in fact getting negative 3/4 at home as well. There are going to be a few baking and cooking questions in this section's homework, and the formula you'll want to use for those questions that ask how much of a certain ingredient is needed is you're going to take the desired serving size and you're going to divide it by the recipe serving size, and then you're going to multiply that answer by the ingredient amount in the recipe. So we're going to be using the right side of this formula, and I'm going to go ahead and take a look at example 4 so we can see this formula in action. It says a chocolate chip cookie recipe for 5 dozen cookies requires 3/4 cup of sugar. If you want to make 8 dozen cookies, how much sugar is needed? So whenever it's asking for some sort of ingredient amount, that's how I know to use this formula. The desired serving size, how much we want to make when it's all said and done, is 8 dozen of these cookies. So I'm going to plug in 8 dozen into desired serving size. That means it's going to be the numerator part of that fraction. So 8 is the desired serving size. The recipe serving size, how much the recipe is designed to make, is right here. Recipe for 5 dozen cookies. So 5 dozen is getting plugged into the denominator times the ingredient amount in the recipe. Well, the recipe calls for 3/4 cup of sugar. So I'm going to do 8/5 times 3/4. What's nice about multiplying fractions is you do not have to have the same denominator. You can just multiply right across the numerators and denominators. On top, 8 times the 3 for, of course, 24. On the bottom, 5 times the 4 for 20. Now I'm going to reduce 24 over 20. Well, the top and bottom are divisible by 4. Or you can reduce it on your calculator if you prefer, but when you do reduce it, let's see, 24 divided by 4 gives you 6. On the bottom, 20 divided by 4 gives you 5. I have an improper fraction, but if you think about it, leaving your answer as an improper fraction does not make sense in the context of this question. If I'm baking, I would never say, you need 6/5 cup of sugar. You would rewrite an improper fraction as a mixed number, and then it would make much more sense. So thinking back to that video where we were going back and forth between improper fractions and mixed numbers, let's divide it out and format our answer as a remainder. So 5 obviously goes into 6 one time, which gives me 5. Subtract 6 minus the 5 for 1 again. No digit to bring down, so this 1 is a remainder. So I get 1 remainder 1. Let's rewrite it so it makes sense. So 1 is our whole number. Take your remainder 1 and throw it over the same denominator, which is 5. So now we can see the final answer. If we wanted to make 8 dozen cookies, we would need 1 1/5 cup of sugar.